Hi, my name is Yusuf,
My name is Muhammad.
and we're going to talk about random number generation and cryptography.
Okay, so what is random number generation? So it is a process by which a random number generator generates a sequence of numbers or symbols that cannot be reasonably predicted better than by random chance. This means that the particular outcome sequence will contain some patterns detectable in hindsight but unpredictable to foresight.
So now we're going to talk about generating randomness with a given probability distribution. So there are a multitude of ways in which you can generate random numbers, but when you pursue such a task according to a given distribution f, one could use the inverse transform sampling method, where you can apply it in all cases where an explicit expression exists for the cumulative distribution function of the random variable. So where x is a random variable whose distribution is represented by f sub x, you can find values of x that are distributed according to f sub x. Then we generate a random number u from the standard uniform distribution, and then we find the inverse of f sub x. And once we find the inverse of f sub x with respect to u, that'll be our answer.
Okay, so now let's talk about how computers generate random numbers. There are several classes of random number generators. The first one is the true random number generators, or TRNGs, pseudo-random number generators, and hybrid random number generators. We will discuss the first two as they are more common. So the first one usually generate their random numbers through observations of phenomena outside of the computer. This could be as simple as the mouse clicks or movements. This is also what we call entropy harvesting, which is collecting data from unpredictable environmental conditions. Now, the second one, unlike TRNGs, pseudo-random number generate random numbers which appear to be random, but they're not actually random. So, broadly speaking, there are two main components of pseudo-random number generators. The first one is the seed, or the initial value, and then the algorithms to produce the random numbers. The way it works is that it receives an initial value, and then a series of mathematical transformations is applied on the seed to generate a new random number. So, in the realm of cryptography, there are a number of challenges that researchers are actively working on. One of the biggest challenges is, of course, how to keep it safe from attackers. All they need is like the knowledge of the generative function with which they can decrypt the entire system and consequently corrupt or steal any crucial data. Another challenge is that pseudo-random number generators, which are thought to be secure, actually have issues like existence of backdoors and improper implementations.
So verification, are the numbers truly random? So identifying whether a random number generator is indeed random could be a challenge, and thus we need robust tests to ensure the sufficient generation of random numbers. One such test is the spectral test, which can be tasked with testing the quality of linear congruential generators, which are algorithms that yield a sequence of pseudo-randomized numbers calculated with a piecewise linear equation. Now, the outputs of this LCG, or linear congruential generators, are plotted on hyperplanes and dimensions 2 through 6. The spectral test compares the distance between the hyperplanes, which, when examined, can help evaluate the accuracy of the generator, as the distance between the planes should be kept to a minimum. It's known that when the distance is smaller, then it's a better random number generator. Random number generation is widely used in today's world in areas including machine learning, statistical sampling, and cryptography. One way that random number generation is used in machine learning is data collection, where machine learning algorithms will typically construct different models when trained with different data. Randomness is also used in neural networks, as it is known as good practice to shuffle the training data before each iteration in deep learning. In addition to being very important in machine learning when it comes to data, statistical sampling, which often utilizes random numbers, is a very important methodology used in a plethora of fields. Using either random number tables or random number generation software, researchers will choose random samples from a population to collect data. Now my friend Fadli is going to talk about cryptography.
To the main theme of our project, that is, where's random numbers used in cryptography? So any crypto system, or at least most of them, require random numbers to generate keys and nonces, regardless of the cryptographic algorithm used. The methods of keys and nonces generation is a whole other domain in cryptography, which we will not discuss in detail here. The point is, cryptography is really the application of random number generations. Now, we say a pseudo-random number generator is cryptographically secure if it has the properties that make it suitable for use in cryptography. And we have a name for this. We call it Cryptographically Secure Pseudo-Random Number Generator, or CSPRNG. To earn this name, there are requirements needed to be satisfied. First, they must pass statistical randomness tests, and secondly, that they hold up well under serious attack, even when part of their initial or running state becomes available to an attacker. More specifically, it is required of every cryptographically secure pseudo-random number generator to pass the next bit test and withstand state compromise extensions.
Thank you for listening to the presentation.